To start with the concepts of groups and subgroups here in abstract algebra, let's talk about the fundamental concept of binary operation. This is not just any operation. There are conditions or criteria that should be met before a certain operation is called a binary operation on a certain set. Yes, we'll be using this as we talk with groups and subgroups and even ultimately the higher topics here in abstract algebra. So we can actually define binary operation in this manner. A binary operation, let's say star, generally it's indicated as star, but we can also have some specific examples later on a certain set S, okay, is a function, let's say here star is the mapping of your Cartesian product of S with itself into S, okay, where for every, okay, A and B which are element of S, the result A, let me place it here at the bottom, the result A star B is also an element of S. In short, it's called a binary operation if that operation on a certain set S is closed under that certain operation. Because if we're going to pick here the Cartesian product, you might be choosing here a certain ordered pair, in this case elements A and B, so you will have here the ordered pair A and B. Okay, if you're going to implement that said star, if it's also an element of S, then definitely we call it a binary operation. That's the criteria for a certain operation to be called a binary operation. It should be closed under the set operation on the given set. Now, one of the examples here that we can try is, of course, the addition, okay? Addition operation on integers, okay? On the set of integers. If we're going to talk about addition on a set of integers and pick any integer, if we're going to add them, let's say C and D are element of your Z or integers. If you're going to have C plus D as plus is rather your operation here, it's still an element of integers, because no matter what type of integer you're adding, whether it's a negative or a positive or a neutral integer, let's say 0, the resulting for that, the sum, will always be an element of Z. Okay, this means that the addition, a more specified example of a binary operation on Z, is actually called a binary operation on Z. Now, it's very important to take note that there is an identification of set S, in this case set Z, because not all the time where our operation indicated is closed under the same set. Let's talk about another example here. Let's say we have here the subtraction operation, let's say on Z. This is still a binary operation, because if you're going to subtract integers, it will still fall on integers. However, if you're going to use here subtraction on Z plus, meaning the set of positive integers, this is not possible to be a binary operation, because if you have examples of integers, let's say 2, and then you have here 5, and if you have here 2 minus 5, this is no longer an element of Z plus, because you will have here negative 3, not an element of Z plus. So that would mean a certain operation may be a binary operation on a certain set, but also may not be a binary operation on this given set. Example, just like this. Another example of binary operation is the multiplication, okay, on the set of real numbers. Because if you're going to multiply two real numbers, it will always result into a real number. Okay. Another example is the matrix addition. Okay. Matrix addition for, let's say, for this m by n. Okay. We know that for matrices, please try to review that one, we can only add, or the result is defined if the size of our matrices are actually the same. Let's say a 2 by 3. So you have here, say, A11, A12, A13, A21, A22, A23, to be added with another 2 by 3 matrix, let's say B11, B12, B13, B21, B22, B23. The sum of that, according to matrix addition, is only the sum of their corresponding components. So you have here A11 plus B11, A12 plus B12, A13 plus B13, A21 plus B21, A22 plus B22, A23 plus B23. The result is still a 2 by 3 matrix. Okay? This means that the matrix addition for matrices M described as M by N is also a binary operation for the same set. So what I'm pointing out here is it's important to identify what type of set are we talking about, because examples like this may have different conclusions if we have different types of sets. But nevertheless, the point here is a binary operation star, or what you call specifically defined on a certain set, is considered to be a binary operation if it's closed, meaning the resulting value or expression using the set operation can be found on the same set. We will have more examples into this and probably verification whether the given binary operations rather are binary operations in a given set or not. Thank you very much for watching.